The first augmented reality systems were traditionally built using three foundational blocks: the infrastructure tracker unit, the processing unit, and the visual unit. Welcome back. In our last episode, we defined the spectrum of immersive technologies. Today, we peel back the curtain to look at the engine under the hood. How does a device actually blend a digital image into the physical world so seamlessly? We are diving into the architecture of augmented reality systems. The architecture of AR systems. The first augmented reality systems were traditionally built using three foundational blocks: the infrastructure tracker unit, the processing unit, and the visual unit. Let's break down how these three components work together to create the AR experience. The infrastructure tracker unit. This is the system's eyes and ears. Its job is to collect raw data from the real world, such as your location, the direction you are facing, or the layout of the room. Some designs even include a video-in module to capture live video feeds specifically for this tracking unit. The processing unit. This is the brain. It takes the data from the tracker and performs the complex math needed to mix virtual content with the real-world data. It ensures that the digital object stays pinned to the right spot in your view, even as you move around. The visual unit. This is the output. Once the processing unit has combined the real and virtual worlds, the visual unit sends that result to your eyes. Two types of visualization technology. How you actually see the final result depends on the visualization technology being used. There are two primary types: video see-through. This uses a head-mounted display, HMD, that employs video mixing. It captures the real world with a camera, mixes it with digital graphics, and then shows you the combined image on a closed screen inside the headset. Optical see-through. This is a more transparent approach. Instead of a screen, it uses optical combiners. You look through clear glass or plastic, and the digital images are projected directly onto those lenses, allowing you to see the real world with your own eyes, while digital data is floated on top of it. Conclusion. Understanding this architecture is key to understanding why AR has become so powerful. As processing units get faster and tracker units get more precise, the line between the real and the virtual continues to blur. In our next episode, we will see how this architecture is put to work in the real world, from the classroom to the operating room.